Assalamu alaikum. In this video, I will explain how can you use integration by parts and how can you get the volume using integration. This example, he say using integration by parts to show that integration e power 2x cosine 2x dx equal to the right side. In the beginning, this is the first question. So in the beginning, we have to get this one first. But how can we get it? We will see how can we solve this problem. So we're gonna start with A. He need to calculate the integration equal integrate e power 2x cosine 2x dx. In the integration by part, you have to think about which one is u and which one is dv by dx. U should be the value like ln x, the function like ln x or x squared or whatever. But here you have e power 2x and cosine 2x. And both of them, there is no end for this integration or for both of them. So how can we select? Actually, it doesn't matter about the selection in this way here because both of them cannot be end or there is no end for both of them. So here I will select u equal e power 2x and dv by dx equal to cosine 2x. After that, you can get du by dx equal to 2 e power 2x, and here the integration will be cosine is coming from sine, so this one should be sine 2x, but there is no integration, there is no differentiation of the angle here, so you have to divide by the differentiation of the angle. So the integration will be this part times and minus v du by dx. So the integration is equal to uv minus integration v du by dx. This is the formula of integration by part. Okay, so here in the integration will equal by substitution, u is e power 2x times half sine 2x minus integration v, which is half. You can take half out of the integration or you can keep it inside. Okay, let us keep it inside for now. Here half v half sine 2x and v times du by dx. Du by dx is 2 e power 2x, and you have to write dx at the end of the formula here. Here you can find 2 can be cancelled with 2, so it will be integration e power 2x sine 2x. Okay, then I which is semaphore integration equal to half e power 2x sine 2x minus integration e power 2x after cancelling half with 2 sine 2x dx. Again, there is another integration appear in this side which includes e power 2x and sine 2x. You have to repeat integration by parts once again, but try to stick with the option in the choice in the very beginning. For example, you select u equal e power 2x, stick with it please, and du by dx it will be 2e power 2x, and here dv by dx equal to sine 2x. So v equal sine coming from cosine, but should be negative. So I have to put negative here. And there is no differentiation for the angle, which is 2. So I have to divide by the differentiation of the angle and repeat the part, which is this part uv minus integration, and this one times. It will be the integration in this part. It will be e power 2x times negative half cosine 2x minus integration negative half times 2 e power 2x cosine 2x, and at the end you can put C arbitrary constant, which is due to the integration. Here another 2 with 2 here with half, so you can be cancelled. It can be cancelled. So and you have negative and the negative inside, it will be positive. But here you have negative half e power 2x cosine 2x plus integration e power 2x cosine 2x plus c. You can think about what is this part. Did you see this part before? Yes, you already done it. How? Actually, this part is the integration in the beginning, the very beginning. If you return back to the very beginning, this is the integration in the very beginning, which I call it I. So instead of using this part, you can cancel it and you can write I instead. But here, this part equal negative half e power 2x cosine 2x. And instead of writing integration e power 2x cosine 2x, you can replace it by I. And then plus C or whatever, anything, which is called arbitrary constant. Okay, this part should be returned back to the original formula, which is here. I equal half e power 2x sine 2x minus integration. And this integration equal the part here. So you have to write then my integration I equal to half e power 2x half e power 2x sine 2x minus the integration, which you already done here, negative half e power 2x cosine 2x plus I, and you can write the arbitrary constant here at the end. It doesn't matter about negative or positive because it's already just constant, so you can leave it outside. Here you can expand this bracket and multiply it by negative. It will be half e power 2x sine 2x plus half e power 2x cosine 2x minus I plus c. And here you have I. So you have I at the right side and the I on the left side here. So you can move the right side, which is negative, to the other side with opposite sign, which is positive. So you at the left side, you have 2i. And instead of 1i, it will be 2i equal to half e power 2x sine 2x plus half e power 2x cosine 2x plus c. You can divide it by 2 to have just I. So I in this case equal to quarter e power 2x sine 2x plus another quarter because you divided by 2 e power 2x here and cosine 2x plus c. So what about I divide that constant by 2? It's constant. It doesn't matter about the value. Constant, just constant. You can leave it c. So I have quarter e power 2x as a common factor between these two, the first two terms. So you can write it like that. I equal quarter e power 2x and open bracket sine 2x plus cosine 2x. And at the end put the c, and this part which is he needs to prove it, and you already get the value which already he needed. So in the beginning he need to disprove, and then you get the right side, e power 2x sine 2x cosine 2x divided by 4, and you already have 4, and you have e power 2x and the arbitrary constant which is c at the end of the formula here. This is the first question, question A, and how can you use integration by part to get the integration that is needed in the problem. So the second question is figure 4. shows a sketch of the part of the curve with equation y equal fx, where fx equal e power x cosine x. So here, this is a figure which reflects the formula e power 2x cosine x here, and the finite region R, shown shaded in figure 4, is bounded by the curve, the positive y-axis, the positive x-axis here. So this is a shaded region which is bounded by y, by x, and by the curve itself. The region R is rotated through 2 pi radian. So when you see anything rotate, he will ask you about the volume. Anything rotate by 2 pi or whatever pi, any angle he give it to you. So there is a volume here. About the x-axis to form a solid revolution using the result from part A, find the exact, he need exact here. And as I mentioned before, exact mean maybe fraction, maybe in terms of pi, maybe in terms of e, maybe in terms of ln, and maybe third root. Okay, so the exact volume, the exact value, any exact value in A2 mass may be in 5 form, which is fraction, pi, e, ln, or third. So how can we get the volume in this case? Let us see how can we get it. Actually, to solve problem B, to get the volume, there is a formula for the volume, which is pi integration y square dx. This is a formula of how can you get the volume. And actually, you already have what? You already have the formula for y equal, y equal e power x cosine x. So here you can replace y square and write ex cosine x all squared dx. You can distribute square to be pi integration e power x all square, it will be 2x, and cosine square x dx. But you have to think. You have to think about what? You have to think about part B and part A. He asked you about in part B here. He asked you in part B to use part A. But if you compare between whatever you get and write to get the volume and part A, you can find that the integration is e power 2x cosine 2x. However, you have here in your integration, you have e power 2x, which you already have in the top one. But actually here you have cosine square, but in the top he had cosine 2x, not cosine square. So you have to think, how can you convert cosine square x into cosine 2x? It is very easy to get it by here. You have cosine 2x, cosine double angle equal to 2 cosine square x minus 1. So here you can take 1 here. So 2 cosine square x equal to 1 plus cosine 2x. You can divide it by 2. So cosine squared x equal to half plus half cosine 2x. In this part, you can substitute it. Instead of cosine square, it will be half plus half cosine 2x. Then you convert cosine square into cosine 2x. So here, the volume equal to pi integrate e power 2x times half plus half cosine 2x all dx. You can distribute e power dx here and make expansion, and then we can simplify it. V equal pi integrate half e power 2x plus half e power 2x cosine 2x dx, and all of it in the bracket. Actually, there is properties or characteristics for integration. You can distribute the integration. How can you distribute it? You can say, for example, volume equal pi, not V. by and open bracket integrate half e power 2x dx. You can split, the integration can split each term individual, okay, like that. Plus integrate half e power 2x cosine 2x dx and close the bracket. Actually, you can take this half out and this half out if you want. So it will be the volume equal by half integrate e power 2x dx plus half integrate e power 2x cosine 2x dx and close the bracket. You can, if you notice that this part, you can notice this part is the part you already get it in part A. So you can replace it by part A. So in this case, the volume equal by half. What is the integration of e power 2x? The integration of e power 2x, it's half e power 2x times half plus half. Open another bracket and write whatever you get in part A. Okay? The part you get it in part A, which is quarter e power 2x, open bracket, sine 2x plus cosine 2x and close the bracket. And the large bracket here, which is multiplied by pi. So the volume is by half times half, which is quarter e power 2x plus, you can multiply by here, 1 over 8, 1 over 8, sorry, just a second, please. Okay, 1 over 8, it will be 1 over 8. 1 over 8. Okay. E power 2x sine 2x plus cosine 2x and close the bracket. Now, this is, you already finished this integration, but there is something about, some students think about where is the constant plus c, which is arbitrary constant. Actually, we put constant if there is no limits for integration, but here you have a limits for integration. But what are these limits? So you have to write here x1 up to x2. What is the value of x1? It's very easy and it's already cleared from the diagram, which is equal to 0. So if we return back here to the figure, x equal to 0 at the beginning. So what is about the x at the end? You don't have anything about the x at the end. But actually at the end, you know that. You know at this end, y equal to 0. So you have a condition at the end which is equal y equal to 0. You can find x at this part. So how can you get the limit? Limits of integration. The limits at the beginning, x1 equal to 0, which is very easy. But the second one, I need x2. But how can you get it? At x2, you know already y equal to 0. And y equal e power x cosine x equal to 0. So you have two options. The first option may be e power 2x equal to 0. And this is reject. Because e power x cannot equal to 0. So you have cosine x equal to 0, and according to the figure of cosine, here pi over 2, and here 3 pi over 2, and here is pi. So actually I have this answer, which is pi over 2, which is the first option. So you will use here x equal pi over 2. يبقى here x2 equal by over 2. يبقى this is your limits, which is equal, x equal 1 equal to 0 and x2 equal to pi over 2. So you can write integration now from x equal to 0 to x2 equal to pi over 2. Now you can substitute by this value. Let us see here. Okay, let me split the screen. Okay, here and here. Volume equal by, open the bracket, quarter e power 2x, x equal to pi over 2, it will be pi, plus 1 over 8 e power pi, open bracket, sine 2 times pi over 2, it will be pi, plus cosine pi. يبقى this is the first bracket, okay, minus the second bracket when x equal to 0, quarter e power 0 plus 1 over 8 e power 0 times, sine 0 plus cosine 0 as well. This is second bracket, and then close it because all of them multiply by pi. Okay, so here the volume equal by quarter e power pi plus 1 over 8 e power pi. Okay, what about sine pi? Actually, sine pi equal to 0. Sine pi equal to 0. According to the sine wave like that. Sine pi equal to 0, but this part equal to 0. Cosine pi equal to -1. يبقى here 1 over 8 e power pi times the -1. Okay, this is the first bracket. Minus the second bracket, which is quarter e power 0, which is equal to 1. يبقى this part equal to 1. And this part equal to 1. What about sine 0? Sine 0 equal to 0. And the cosine 0 equal to 1. At the second bracket, you have 1 over 4 plus 1 over 8. This is the second bracket. And close the big one, because all of them multiply by pi. We need to simplify. The volume equal by 1 over 4 minus 1 over 8. It will be 1 over 8 e power pi. This is the first one. Minus pi, because I will use this pi as well with the second one. Quarter plus 1 over 8. It will be 3 over 8. It will be 3 over 8. You can write it here then. Equal pi over 8 e power pi minus 3 pi over 8. This is the volume. You can get it. Okay, can you calculate the value of the volume? Actually, you did it. You don't need to calculate it because you already need the exact volume. Exact volume, you have to leave it as y or as e. Okay, thank you for watching this video, and I hope this video is useful for you to understand how can you use integration by part and how can you get the volume. Thank you for watching, and see you next time, inshallah, for another videos. Thank you.